Hello everyone. Today we have Pre-Calc lesson 50, trigonometric equations. We've been doing a lot with trig equations. This is going to be just a slightly different rule or a different thing we're going to do. So in trig equations, right, if we are asked to solve a trig equation, technically we could get an infinite amount of answers. Right? We could go around 360 over and over and over and over and over. We don't want an infinite number of answers, so we restrict our range. We say that theta is going to be either from 0 to 360 or from 0 to 2 pi. Okay, so let's look at an example of that. If we want to solve the sine of theta is 1 over root 2, given that theta is in between 0 and 360. So I'm going to draw my reference triangle. I know this is from my 45, 45, 90 triangle, 1 over root 2. And I know that the sine of 45 degrees is 1 over root 2. So theta can be 45. Okay, now let's look at our graph. 45 degrees is here. And we remember that all students take calculus. Sine is positive here. It's also positive here. So theta could also be 135 degrees. Now let's look down here in the lower quadrants, right? We cannot have sine here or sine here because that would give us a negative value. We don't want a negative value. And we also can't go all the way around and do 360 plus 45 because that wouldn't be in our restricted range. So these are my two answers for theta. All right, let's do another example. Solve 2 plus root 3 secant of theta equals 0. I'm first going to isolate secant of theta, so I'm going to subtract 2. So I will get root 3 secant of theta is negative 2. Divide both sides by root 3. So we get the secant of theta is negative 2 over root 3. Okay. Now, I'm going to draw my reference triangle. This is my 30, 60, 90. I have root 3, 1, and 2. Secant of theta is 1 over the cosine of theta, and it's negative 2 over root 3, which tells me that the cosine of theta is going to be negative root 3 over 2, the reciprocal of both sides, which tells me that theta is related to 30 degrees, right? The cosine of 30 degrees is root 3 over 2. But we have to look at this negative. All students take calculus. We know we're not going to be in the first and fourth quadrants. We know we're going to be over here. We want the 30 degrees here and 30 degrees here, so that cosine is negative. Now, so I can say theta here will be 150, or 180 plus 30 gives me 210. That is not my answer though. Look at your restrictions. Your restrictions are given to you in radians, so your answer has to be in radians. Okay, so we know that this is pi over 2, this is pi, 30 degrees is pi over 6, so we could say this is 6 pi over 6, giving me that theta is 5 pi over 6, or theta is, right, we've gone pi over 6 past 6 pi over 6, so theta is 7 pi over 6. You could also have just done that by doing 150 times 2 pi for 360. Okay. Now, your book sometimes gives the answers in degrees still. That is incorrect. I want you to, if you're given the restriction in radians, you have to give your answer in radians. All right, and one more example. Solve 3 root 2 plus 3 cosecant of theta equals 0. So again, I'm going to subtract 3 root 2. So I get 3 cosecant of theta is negative 3 root 2. And I divide everything by 3, giving me the cosecant of theta is negative root 2. So I'm going to draw my reference triangle, 45, 45, 90. Now I know that the cosecant is 1 over sine of theta, gives me negative root 2. So the sine of theta is negative 1 over root 2. the reciprocal. Okay, so again, we draw our graph. All students take calculus. Sine is negative, which tells me we're going to be in this quadrant or in this quadrant. Okay, now 1 over root 2, this tells me that theta is 45 degrees. Okay, so I'm concerned with the 45 degrees past 180, 45 degrees less than 315. So it tells me that theta is 225 or 315. Okay? So trig functions, you need to be aware of the different boundaries that they give you, and if they give you the boundaries in radians, you need to write your answer in radians. All right, that is all for today. You got 2 short videos in a row. We will see you tomorrow.